All right, well, thanks everyone for joining us today. We're excited to have another of our Scripps technical forums happening virtually. My name is Vanessa Scott, and I lead industry relations and innovation here at Scripps Institute of Oceanography at UC San Diego. And I am a host and moderator today, standing in for Douglas Alden, who is the director of the Scripps Technical Forum and is working in the field today. So again, we ask that everybody stay on mute during the presentation and feel free to put your questions in the chat and at the Q&A icon at the bottom center of your screen throughout the talk, and we'd be happy to moderate. I know Chad will be interested to have questions coming in throughout, and there'll probably be time at the end to answer some more. Again, we welcome any ideas and companies and topics that you'd like to hear from. So please feel free to reach out to either Douglas or myself to submit those ideas, and we can coordinate accordingly. This will be recorded and posted to our Scripps Technical Forum playlist on the Scripps Oceanography YouTube channel and also on the Technical Forum website. And with that, I'm excited to introduce our speakers with SubC Imaging today, who will be talking about the new remote operations technologies for ocean sciences, offshore energy, and more applications. And today we have Chad Collett, who is the founder of SubC Imaging and the CEO, as well as a camera systems manager. Quick bio about Chad. He is a trusted leader in deep sea cameras, subsea systems, LEDs, lasers, and software solutions for marine research, offshore energy, aquaculture, fisheries, and more. Part of Chad's focus is driving forward the technology of SubC's camera-related products and systems. And prior to SubC, Chad started out diving with the Canadian Navy and then worked at NRC Institute for Ocean Technology, Oceaneering, and Wellaptega Marine. Sorry if I mispronounced that. We'll also be hearing from Adam Rowe, who is the VP of software at SubC Imaging and also the co-owner. Adam has spent his career developing innovative software applications for ocean-related professionals. He and his team focus on creating cutting-edge systems with intuitive user experiences. And this includes his recent leading work on adaptable remote operations technologies, which you will hear more about today. So I will hand it over to you, Adam and Chad, to take it from here.
Thanks, Vanessa. So, hi everyone. Thank you for joining us. In this presentation, we're covering SubC's new remote operations technology. SubC's customers operate in ocean science and energy sectors primarily. So my name is Chad Collett, CEO and camera system manager at SubC Imaging. I am introducing this topic and presentation for Adam Rowe, our VP of software and the co-owner here at SubC. He will talk you and walk you through some of the challenges we faced while developing our remote operations solutions and some of the things you can watch out for when transitioning to remote ops in your organization. SubC Imaging is a world-class developer and manufacturer of industry-leading underwater systems for multiple industries. We have now added remote operations cloud-based services to our portfolio. We have many clients in many countries, and we have a lot of experience delivering solutions to solve problems. At SubC, we value innovation, continuous improvement, and collaboration with our customers. All of our development and products are driven by a direct need from customers in the science, research, energy, and other underwater sectors. So the agenda today is we will be covering the why of remote operations, then our journey through development of remote operations technology. We'll cover some applications and use cases, and then we'll have an open Q&A session. So now I'll hand it over to Adam to walk you through the rest of the webinar.
Awesome. Thank you, Chad. So first off, we're going to talk a little bit about remote operations and why. So when we talk about more conventional operations of having a vessel offshore, all the crew is on board, and the piloting of the USV or piloting of the ROV is all done from the vessel. That's your more conventional type operation. And then remote operations is more of a series of stages of transitioning to being completely disconnected from the vessel and the ROV. But there's a lot of stages in between that a lot of our clients are in a transition period to get to full remote ops. So we've got a few compelling reasons why some of our clients and some of you might be interested in moving towards remote operations. You get faster feedback from offshore, which leads to accelerated decision-making for key personnel. We can reduce our environmental impact. So this is a really interesting one where if you don't have large vessels with a bunch of people who need to go offshore, you can make things a lot smaller, and we can really reduce the environmental impact that a lot of underwater surveys and inspections take. So that's a really a great compelling reason to kind of move towards this end. We can reinvest some of our savings into other projects by reducing some of the costs associated with vessel maintenance and crew and all that sort of thing. Risk mitigation, and we can improve crew safety by having less people working in harsh environments and have those back on shore. So why remote operations for subsea? We have been working in the underwater, we've been specialist experts in the underwater market for over 12 years now. And we've been developing cameras and lights, lasers, topside recording software. And we've gotten a lot of feedback from our customers and clients that they are interested in moving towards remote operations. And we felt like there was a growing market and a growing opportunity that made sense for us to start transitioning some of our products to be able to work in this new format, this new workflow. So we're going to talk today a little bit about some of the challenges that we faced in adapting our technology to be able to work in this manner. There's a lot of hurdles to overcome when you're developing a system like this to distribute work, and we'll just kind of inform you on what we've done, some of our products that we have and what they can do to help, and also some things for you to look out for when you're working on this yourselves or you're looking to source solutions for your projects. So I've got a quote here just from one of our clients at Fugro. We have been working in this space now for a little over 2 years, and we have been we've been very successful with how our development is going. There's new challenges that we're overcoming all the time, which is a ton of fun for the development team, and it's really providing great value to a lot of our clients. All right, so challenge number 1, real-time video. And this is probably one of the biggest ones to overcome. And basically, it takes a lot of time for the video to be transmitted offshore to onshore using conventional communication methods. VSAT, of course, has quite a high latency. There are some areas that have 4G networks at the inspection site, Tampnet in the North Sea, for example. Starlink Starlink Marine is coming online, and that's an exciting kind of forward-looking technology that looks like it should be a very good application for remote operations. The latency is significantly lower than some of the conventional methods, and bandwidth is often extremely limited. So in order to get the quality of video that you need to be able to pilot and make decisions on that video can be challenging as well. So our solutions to those problems, we've developed a software-based solution to integrate into existing infrastructure. So basically, we wanted a way that users could install our software on a computer that they're already running on board their vessel. We wanted to cut down the integration time so that it can be done extremely rapidly. We could just download our software and link it to a computer, and then any cameras that you have on board that vessel, we can start streaming within minutes. We also have our Viperfish camera that it's in the later stages of development, and basically that will give you the ability to stream directly from the camera itself. So we can do that without requiring a computer on board the vessel. They just need a network connection, and they connect and will start streaming themselves. So some of the major challenges, being able to navigate those networks and those connections using very high compression encoders to be able to take that high definition video and make it small enough that we can get it through limited networks and still be able to resolve high levels of detail on the other end. So another set of challenges that you'll face is communications failures. So communications are inevitably going to fail in harsh environments. That's just the way that it works. They're not always quick to recover. Sometimes if you are out of VSAT alignment, or there's bad weather and things like that, it takes a while to regain that connection, which means the video and data that you're streaming is going to be lost. And we also need the ability to be able to switch between connections. So if you are streaming in a high, in a low latency setting, and for some reason that fails, and we've got a backup set of communications, we need to be able to quickly switch and regain connection so that we can stream as quickly as possible. So what we've done to solve those problems, number one is to get you back online as quickly as possible. Our products are developed in a way that they're network agnostic, so they can just connect automatically as soon as a connection becomes available to any network that is present, and automatically start streaming to the endpoint. So that will minimize the disruption from a video streaming perspective. As soon as communications come back online, without human intervention, we're able to get back up and running and stream all of our video and data through it. But also recognizing that this is inevitable and we don't want to lose any of that video, we've also developed another application, Black Box, to be able to be installed on board a remotely operated vessel and record all that video and data locally to a Black Box drive to be able to recover that in the event of a failure, and or if a disaster took place while communications were down, at least there would be that footage to be able to play back to see exactly what happened, and you can learn how to mitigate those disasters in the future. We've developed that in a way so it doesn't require a dedicated PC. We want to make sure that we don't add any unnecessary additional infrastructure. These vessels typically have lots of computers running on board them that are very high on performance, and then we can install that software onto one of those systems and make sure that all of that is being recorded and captured. So challenge number 3, how do we make sure that no one who shouldn't be able to see our video and data is able to? So we want to make sure that everything is secure, so that internal personnel can view it, but also we do typically need a way to bring in any external clients or stakeholders. So there's a bit of a balance here where we need protection when we do, and then we also need the ability to invite others to get in and see. So depending on which solution, depending on the issue that the work that you're trying to do, the inspection, the survey that you're trying to do, it might make sense to go with one solution over another. So we have different ways of transmitting all of that through a network to the endpoint. Basically, we have a host of redundant cloud servers that are able to transmit that video. Those are all locked down and are distributed across the globe to maintain a very low latency, so we can get that as close to real time as possible. And these are hosted and maintained by SubC. But it might make sense, if you are in control of the entire network, to go with an edge server. So, and what an edge server is basically a set of servers that you would host within your own network, and they would be as close to the endpoint as possible to cut down on the latency going from offshore to onshore. So that way, that's all hosted within your network, and then we'd have a way to be able to invite in external people to view that. A time when the cloud server might make sense is if you're not in control of both networks, you have a lot of external people, you have a really distributed personnel working towards this project, it might make more sense to go with a cloud server, and that will make it more easy to distribute across multiple teams. So then, now that we have our workforce distributed anywhere in the world, it can be challenging to have everyone communicating to be able to coordinate all the work that's being done. And when people are distributed and can work from anywhere, then we need a way of communicating. So our solutions to that is we have the ability to present to external clients. They get emailed an access code to be able to log in and view those presentations. We have a new product, our SubC audio rooms, and that gives us the ability to create private channels to have a conversation, to coordinate all of that work, and to invite in external stakeholders to be part of that conversation. We also have it flexible enough that you can maintain your private conversations without having any external clients or client representatives being part of those conversations. And we also have our SubC DVRO and inspector, and that will do all the recording and overlaying and eventing, and you can do that anywhere in the world. So if you have a video and data coming through and you want to distribute that to multiple researchers or multiple personnel, then we can have our DVROs running and bring in all of that audio and video and data, and all of the eventing and surveying work can all be done remotely. Next, we have vehicle control. So in a fully remote operation perspective, where everybody is onshore, we need to be able to remotely control the USV, the uncrewed surface vehicle, and we need to remotely control the ROV on board it as well. And often different teams are used for both of those. And we need a way of being able to, again, distribute the work and be able to connect everybody together to be able to safely pilot the vehicle. So our solutions for that is we have synchronized video and data in our real-time streaming solution. Basically, we have the ability to take in multiple cameras along with the data, synchronize all that together at the point of capture, and then transmit all of that so that when you receive it on the end, you'll be able to make sure that all of your sensor data and information is in line with your video. This is critical for pilots, as they'll need to see their heading, pitch and roll, their depth or altitude, and make sure that it accurately reflects the video that they're viewing and using to pilot. Also, for data routing, we want to be able to transmit the control system of the pilot from onshore to offshore. So we'll need a mechanism of doing that as well. And we've developed our SubC data routing to be able to be that middle layer that will accept any form of input from your control system, whether it's over network or serial, transmit that to the vessel, and then we have the output side where we're able to take that and output it into the input of the control system of the USV or ROV. So we have a lot of different use cases for this technology. And like I said earlier, it's more of a transition where you might first have everybody on board your vessel, and then you want to just get external client stakeholders involved, and you want the ability to be able to stream video to them. That would probably be the first step. Next, you might want to get your surveyors or your inspection team onshore, and then you might want to stage that across multiple iterations, and with the final goal of having a fully uncrewed vessel that you're able to pilot remotely. So we've developed our technology in a way to basically mold and adapt to whatever point you are in the transition. So we've always developed our technology for traditional and conventional inspections and surveys, but with the forward thinking of being able to work for remote inspections, surveys, maintenance and repairs, remote ROV and USV piloting, and fully remote cloud-based integration. So we have made all of our products work in all those different sorts of conditions, and as you transition to fully remote, it will all continue to work. So here I have an example use case. Depending on what use case you're looking at, this can change. There's a lot of different ways this technology can be adapted, and this is just one that we chose to go over. But we're always interested to hear what problems you're trying to solve, and then we can make sure that the system works well for you. So first off, we have our offshore side with our ROV and our USV offshore. We have our Viperfish cameras, and they can be used subsea as well as on the USV. Of course, you'll need eyes on the vessel as well to be able to pilot it. And all of those just feed directly into the network. So some compelling advantages of the Viperfish over our real-time streaming is that you don't require a dedicated computer to be able to take all those cameras in to do all that streaming. These all act separately and independently of one another. So if there was a critical failure on any one of the cameras, you still have all the other ones available. Versus if you have your computer system running and it goes down, then unfortunately you're going to lose all of your video streams. So we're going to take that into our network. All of that can be black boxed on board the vessel, and we can make sure that all of our data and video is saved. In the event of a disaster, we can recover all of that. That's all going to be streamed through our remote cloud server. And again, these are distributed across the world, so you can always pick one that's closest to you to cut down on the latency of the video and data going through the cloud. That then can be received onshore into our DVRO. And here's where we can start doing our eventing and our inspection work. So we have a companion product, the SubC inspector, and that as well could also be run remotely, where our researcher or the person in charge of doing that eventing is able to be anywhere in the onshore building at your control center. And they're able to work independently and be able to do all the recording and eventing on their own time. That video then can be taken and distributed to the piloting team, and they can have all of their monitors and control systems connected, and all of that video and data can be presented to them. From here, their control system will feed back into our SubC data routing application, and then that will go back through the cloud to the USV to complete the loop on being able to control the USV. So what are some things to look out for in your remote operations solution? Of course, low latency is key. We want to make sure that we're able to effectively pilot the vehicles as while they're offshore. Everyone has a different set of requirements, and you're going to want to make sure that it can be easily integrated into your current setup. So an open API is very important. A lot of people have a lot of complex workflows, and often you'll want to be able to connect your existing system to another system to be able to integrate it. You want it to be able to adapt and evolve as you transition from perhaps conventional to fully remote operations. You want to make sure that your investment is future-proof. You want to make sure that your video and data is secure and that no one is going to be able to view any of your operation that you don't want them to be able to view. You want to make sure that you're able to effectively communicate across your distributed team. That is going to be very important, as well as redundancy in any of the servers that you're using. Failures, unfortunately, occur with complex systems, and we want to make sure that we're able to switch between redundant servers to make sure that mission critical applications are always being able to be viewed and worked on. And look for a collaborative partner, someone who you're able to work with to understand your workflow, your use case, to be able to integrate their technology with yours to make sure that it's a successful project. So we are going to be at Oceans International San Diego next month, and you can speak with our sales team about any upcoming opportunities that you might have, or any upcoming projects, whether they be remote or for any other type of application. And you'll be able to further that conversation with them at that point in time. Of course, you can always email us as well. And right now we're going to open up the floor to Q&A if anybody has any further questions.
Excellent. Thank you so much, Adam and Chad, for a great presentation. To Adam's point, we are now opening it up for Q&A. So please feel free to submit your questions either in the Q&A at the bottom center of the screen or through the chat. I was going to say, while we're waiting, I know that there have been some pre-submitted questions for the webinar. Cannon, do you have any of those you can queue up?
Yes, absolutely. There were quite a few questions in the registration form about artificial intelligence going forward and what are some of the potential uses in the future for ROV applications.
Yeah, so I think as artificial intelligence has become a more prominent, you're going to see a lot of like species classification and all of that sort of stuff done on the video side. It will probably be more a reporting system of here are all the different types of species that we seen during this survey. I mean, that seems like a very logical next step for something like that. Intelligent ways the USV and ROV can kind of react, maintain their position in the event of a communications failure. That will be very important, of course. And so are there management strategies for reducing overheating during data transfer? So depending on where your data is coming into, overheating shouldn't be too big of a problem if you've got a computer system capable of being able to input and transmit that video and data. And given that it should be offshore, you know, that shouldn't be too big of an issue. Chad, I don't know if you want to kind of chime in there and add any of your 2 cents.
For overheating, I don't think that's not an issue we see. I mean, a lot of our systems, a lot of computer systems all have thermal management, and it's not a problem.
We have some spec guidelines that we suggest based on the application. So if you could create a scenario for us, then we would evaluate what that application scenario is, and then we would provide some suggested minimum spec requirements on the hardware.
That's a good answer. Greg Dixon has a question around if whether the Viperfish has computer vision algorithm compatibility. Adam, did you want to speak?
Yeah, absolutely. So our Viperfish is based on the same platform as our Rayfin camera, and those are running very sophisticated operating systems that we are able to integrate computer vision algorithms into if we have future requirements to do that. So yeah, the Viperfish would have that ability once we have that requirement.
And it has a GPU as well, so it would be accelerated algorithms, I guess.
Great. There's another question that was submitted in the registration process that Ken put in there asking, what are the limitations of complete autonomy of vessels and how can they be addressed?
That's a big one. So limitations of complete autonomy, I think we're a long ways away from not having any humans involved in that workflow. Being able to successfully pilot and navigate the vessel to the field to be able to do that work, I think would be very challenging. Right now, you need a team of pilots to be able to get the vessel from onshore to offshore to the site. Afterwards, you would need an ROV or some AUV to be deployed to go and conduct that inspection, to feed all that back in real time. I'm not too sure on what more kind of limitations are in place today to kind of make that a reality.
I would say too, if you have a vessel at sea, it's such an expensive asset, you're probably never going to want it to be completely autonomous. Like you do want some monitoring, especially in an oil and gas scenario, there's safety reasons, but in an exploration or science application, you're going to want something watching it, or someone watching it, right? So complete autonomy might not be practical.
So latency is very important for remote operations. Yes, absolutely. So what round trip latency do you see with your camera and cloud-based connectivity solutions? So the major factor in that is the actual communication mechanism that you're using. If you're using VSAT, you're already limited at around 700 milliseconds. And then the video transmission on top of that is probably about another 200 to 300 milliseconds. So you'd be looking at about a second of round trip. If you use 4G, that drops considerably, and you're down to around 100 milliseconds from our testing. And then the video on top of that again is about 200 to 300 milliseconds. So you're looking at roughly around 500 in an ideal scenario. It will certainly not feel quite as connected as working on board the vessel where you've got, you know, next to 0 milliseconds of latency. But it is something that is achievable and attainable, and pilots are able to effectively work under those conditions.
Great. I think there were some pre-submitted questions we can go off of. Can you recommend ways to identify and reach the decision makers for autonomy adoption on tasks historically done by crewed boats?
Identify and reach the decision makers for autonomy adoption.
I think
So
that might be, oh, go ahead, I'm sorry.
yeah, I guess I'll kind of interpret that as being, how do we present our video and data to decision makers who are probably onshore? And our solution is designed specifically to do exactly that. We have 6 camera inputs that you'd be able to connect all your cameras to, and then be able to stream that through our cloud infrastructure to the decision maker. They would be emailed and activate a secure key to be able to log in and view that presentation. Hope that answers it.
Great. I think this is a great question. Someone had pre-submitted asking about what skill sets are required for these types of jobs with subsea imaging.
So we have a lot of different requirements at SubC. We are not any one type of company where we have a hardware team, we have software teams, we have electronics teams. So Chad, perhaps you want to jump in there and kind of talk to that?
Yeah, we are operating in a high-tech space in a very specific set of markets with a niche, but like Adam said, we have software, hardware, and mechanical and electrical, but we have also operations and a growing sales and marketing team. So the skill sets are varied. I wonder if someone is asking about like the types of jobs to work at SubC, or what kind of skill sets are required to pull off remote operations. Remote operations specifically, it's a very software-centric product and solution. So it's very, and that's intentional. It's designed to eliminate as much hardware as possible in an offshore or an autonomous setting. So very much a software-based and a product.
I just hopped over to the other questions here. I see one, if one purchases the Viperfish, is a software license required? Are there software options? So we're still very open to kind of conversations with our clients on the best way to kind of integrate that product. It will act as a dual camera, where it will be able to be used in just conventional operations as a traditional IP camera. And then it'll also be able to be used for remote operations to stream all that video in real time. And our salespeople would love to have that conversation with you.
There's a good one with latency and also bandwidth.
Yeah, so what extent does vessel comms bandwidth restrict ship-to-shore data transfer? This is a really big problem with getting all that video and data from offshore to onshore. Is the networks, the communication methods are always very limited. So we use, like I said in the webinar, we use really high compression algorithms to be able to get that video down to about 1 megabit per second, to 1 megabit per second for high definition video. And in all of our testing that we've seen that is sufficient to provide, you know, deliverable quality to the endpoint. And depending on what application you're going under, standard definition is significantly less. You're looking at around 256 kilobits per second to get a standard definition feed.
I can answer one about fish farming. So we do have a partnership with it's publicly available information. We're in partnership with ROVS and Grieg. We're both Norwegian companies on an aquaculture R&D project. A lot of this technology does have good parallels with the aquaculture industry. We are open to conversations around how that could be used. We are developing parts of it for that industry specifically, and we'll be doing some sea trials with the Viperfish hardware in particular in March on some aquaculture farms here in Canada. So there's a lot of parallels.
Also, so I think some of the biggest hurdles are going to be, number one, training for your piloting team to be able to work in that remote type of workflow. I think that's going to be a challenge, and making sure that they're able to react and effectively carry out the task. Also, communication failures could be a really big detractor from going to remote ops. If you have unstable networks and you're not able to effectively pilot your USV or your ROV, then that will be a big problem. Of course, like I mentioned earlier, Starlink is a huge step forward for that. There's a lot of work to be done, obviously, but the future is certainly bright for remote operations.
I think that goes to like where the projects are situated. So there's some of our partners that operate in what they would say like high confidence regions where they have their VSAT connection with a 4G network as a failover. So that will add contingency and redundancy to the application or the project.
Looks like another question came in. I think you may have answered that, asking about software licenses with the Viperfish.
Yes. Yeah.
Yeah, I put some text in the box there. I don't know if everybody can see that, but.
Oh, here, and a new question just came in asking about, do you see remote operations transitioning from centralized operation centers to a more distributed network of individuals?
Yeah, absolutely. I can't see a problem with kind of distributing that team over larger areas. Once everyone gets used to working in that manner, I think the requirement for having as many people in one site will be reduced. I expect to see it to continue to go more and more distributed.
I think one of the earliest things that can be distributed is client and decision makers, and giving them access to the live video separate from the people who are driving the ROV or the USV, giving your client, your decision maker, access to view the live data, even if they're on the other side of the planet, is something that's achievable now, right, Adam?
Yeah, absolutely.
So it is distributed already.
So embedding metadata like CTD and position into images and video in real time coming along anytime soon. Yes, absolutely. So that is something that we are doing now, actually, is taking in all of that data and embedding it and synchronizing it with the video frames that get transmitted. So that is something that we are doing now.
There was a question from John at Scripps asking about depth restrictions. Can you speak to that?
Yeah, absolutely. So we have designed our products standard at 6,000 meters, but we do have camera systems of ours down at the Marianas Trench. Chad, you could probably talk a little bit more about that kind of thing.
Yep, no restrictions. Yeah, there's no restrictions on depth. We've got experience with all environmental factors and temperatures. So this can work on the North Pole to the bottom of Marianas Trench. Maybe not the North Pole if there's no satellite connection, actually.
There was a question asked about offshore wind and float photovoltaic, like what's the current state and the future?
Maybe is that regarding power? Perhaps if someone could, is that a pre-asked question? Oh, okay. Okay. Yeah, I could only speculate what they're asking, I guess. If it was power, there are options, there's solutions for offshore wind generated power for monitoring, I guess.
If that was related to like remote operations or remotely accessing an asset in the water that isn't tethered to a power source, then you could have, you know, some solar power on a buoy, or have some wind energy assets to power that. And if you had a 4G network, then you could remotely access that camera, and then that camera could then be accessed, you know, in your home or in your office.
That
So
is definitely in the realm of possible.
There is a solution there. I would say location would be the biggest caveat to that, and what type of budget you have for infrastructure.
Agreed. And we excel at helping solve challenging problems. That sounds like one. So, you know, if you are interested in having a conversation, reach out to us.
Excellent. I think there are a lot of really great questions. Don't see any more coming in. We have a few more minutes. If anyone has any final questions or thoughts, you can also feel free to raise your hand and we can unmute you if you'd like to ask it yourself, or you can put it in the Q&A in the chat. But while we're waiting, I just want to thank you for a great presentation. I think it was really informative and very exciting on your guys' new capabilities. Any final thoughts or any resources you can point people to if they have more technical questions that come up?
Yeah, absolutely. Feel free to email us at our sales line, view our website. We have a new landing page for our remote operations tech on our website. So there should be some information available there if you're looking for more information about it.
Excellent. Oh, I see another one that just came in the QA. How much power does each camera system use?
While the cameras are running, I believe it's about 8 watts of power per camera. That might be slightly lower as well. That's while recording video. So 8 watts or lower. And yeah, that's without lights. So if that's just the camera, lights are more power intensive.
Great. All right, well, I think we've got all the questions that we had come in. Thank you again for a great presentation. If anybody has any questions that come up, obviously you can email myself or Douglas or anyone at SubC, and we can make sure that you guys get the follow-up that you need. And yeah, we look forward to seeing you here in San Diego, gosh, next month. And thank you again for everybody that's logged on. We appreciate your participation in the technical forum presentations. Again, we are always open and welcome suggestions for topics and companies and technologies and ideas. So please feel free to reach out to myself or Douglas Alden or my colleague Cannon Purdy to submit your ideas. And with that, yeah, this recording will be posted on the technical forum website afterwards. So if you missed it or if you have colleagues that you think would like to see it, you can always point them there. With that, I will say thank you again to everyone and look forward to seeing you all soon.
Thanks, Vanessa.
Thank you.
Thank you.
Thanks, everyone.